Hello chemical engineering fanatics. Today's lab is batch distillation using a bubble plate column. The objective is to have a successful separation of ethanol and water using batch distillation. We'll be going over a bit of theory that's related to the distillation, as well as safety and procedure and waste cleanup. What is distillation? Well, it's a method of separating components based on their difference in boiling points. The greater the difference in boiling points, the easier the separation. An azeotrope. An azeotrope occurs when the two liquids cannot be separated by distillation anymore because when the mixture is boiled, the vapor has the same compositions as the unboiled mixture, and ethanol and water form an azeotrope at about 78 degrees Celsius. Decay theory requires us to plot the vapor equilibrium data in a graph and compare the x and y terms. After this, the operating line is then drawn and its equation is given here. The equilibrium line is drawn by measuring the concentrations from the vapor component and liquid component samples that we measured using the refractometer. We can now begin staging by drawing straight lines across the equilibrium line and straight up towards the operating line. After this is done, we have an idea of how many stages are required for the separation. When in the lab, it is important to follow proper safety procedures. This includes proper attire, protective equipment, and following protocols to ensure the safety of you and your classmates. Before going to your lab station, take note of where things such as safety equipment like your eye wash and waste disposals are. These can be found on your local safety map. Note the locations of your first aid kits. This one is located behind the door of the entrance. The next one is located towards the back of the classroom. You must wear your goggles at all times, as well as your lab coat to prevent chemicals from getting in your eyes or on your skin, as most of them are irritants. Gloves must be put on before handling any chemicals whatsoever. Handle chemicals like you would your phone. Don't drop them, as we don't want any spills to endanger you or your colleagues. Also be careful that the temperature of the column does not get too hot, as we don't want any explosion of glass. Ethanol is not for consumption, nor is it very good for your skin or eyes, as it is an irritant. Also beware of any electrical shock that can occur from the mishandling of the heater or spills that occur around the heater. Here is the full setup of our distillation equipment. The pot here contains the mixture of ethanol and water, and inside of it is the thermocouple that is used to measure the temperature of the system. Here what we can see is the 5-stage plate column. What you may not be able to see from this view is that the trays being used are bubble cap trays. Here we have our reflux, which uses valves to control the flow of the vapor that goes back down into the column, as well as the condenser, which condenses the water vapor into the liquid. First, we will take a sample of 1 milliliter from the mixture to analyze in the refractometer. We will first begin by turning the chiller on, which needs to be on 20 minutes prior to beginning the experiment. Now turn the heater on to 120 volt power and set it at 80%. Once the heat has been on long enough, you will begin to see the temperature increase on the thermocouple. Watch temperature closely, because if it goes past 85 degrees and there is no formation of bubbles in the boiler pot, immediately notify your TA, as this can lead to superheating and cause the glass to break. You definitely don't want this happening. As you can see here, we had no problems with this, as we got bubbles. The column is operating at total reflux, meaning that the vapor can move up and liquid can move back down freely in the column. Monitoring the temperature, we will allow the system to reach steady state by recording the temperatures at the top and bottom of the column every 2 minutes until we no longer see a significant difference in readings. Once we reach steady state, we will take a sample at the top as well as the bottom so they can be analyzed using the refractometer. After 10 minutes, we will do this again to confirm that the composition has not changed. One of the key aspects of this lab is looking at the flow rate of the vapor through the column. To carry this out, we'll set the reflux ratio at 50% by opening the valve on the left and using the valve on the right to adjust the flow rate until we have what we want. At this point, the distillate rate should be about half of the boil-up rate. In order to measure this, we'll collect the distillate in a graduated cylinder and measure volume with time every 5 minutes until we have about 100 to 150 milliliters of the distillate. We'll also be taking temperature readings at the top and bottom in 1-minute intervals. Now we have our refractometer, which we'll use to measure the refractive index of the samples to determine the ethanol concentration of a sample. Before using it is important to clean the refractometer using a chemi wipe. Here we have the preparation of the samples before they are put into the refractometer to be analyzed. After you've completed your experiment, it is important to dispose of everything properly. Here we have the disposal unit for ethanol. It's kept under the fume hood, and shut the fume hood once the ethanol is put in the container. Water can be disposed of in the sink. Also, don't forget to clean all your equipment using distilled water. Thanks for watching. We know you don't really have any questions because, well, this was an excellent explanation of the lab.